How to write, solve, and graph inequalities. This is topic 4. Now today we're going to write and solve inequalities, graph and analyze a graph on a coordinate plane to solve problems involving inequalities, interpret how a negative rate affects how to solve an inequality. So now look at this one right here. You can solve an inequality in much the same way that you solve an equation. You isolate the variable by using inverse operations. However, there's one major difference. When you multiply or divide, it doesn't matter which one, multiply or divide both sides of the inequality by a negative number, you must, and I repeat, you must reverse the inequality sign, such as right in this one right here. Now, when you're looking at inequalities, always make sure the variable is on the left-hand side. This one right here is written backwards, because if it's not written on the left-hand side, when you go to graph it, it will be written wrong. So when you reverse it, like 5 is less than x, then you're going to make sure that you have x is on the left-hand side, but you also have to flip the less than, it becomes greater than, and then put the 5. You have to flip the entire thing, not just the x and the 5. Now, you cannot, as I said before, cannot have a negative variable. If you divide everything by -1 and turn the, if you do divide everything by the -1, you must turn the inequality sign around, such as this right here. This is a -1x right here is greater than 2. You can never ever leave a negative variable in a final answer. So this is like saying a -1 over -1x over -1 less than 2. And just go ahead and stick it over a -1, divide it by a -1. And a negative divided by a negative gives you a positive. So a -1 divided by a -1 will give you a positive x. 2 divided by a -1 will give you a -2. Now, when you look at this right here, notice that the symbol right here was greater than, and it has been reversed right here, and it's less than. So x is less than a -2. Now, look at these right here. The first thing that, in order to read these, you read these from left to right. So I come over here from the left-hand side and I see I have a little point. That means less than. So as I look at this right here and write less than, and I'm going to write this. So look at this for less than. If I have the symbol less than, I can make the letter L out of it. And when we write the symbol for less than, and when we go to graph it, notice that this right here is pointing to the left. So if it points to the left and there's no equal underneath it, it's going to look like this. An open circle, and the graph is going to go to the left. When we look at this one right here, this has the first thing we come to on the left-hand side is a open mouth. So we read this as greater than, because it's an open mouth. There's no equal there, so it is a open circle. And notice that this points to the right, so this is going to point to the right. Now, if there is a greater than equal there, and these are the words at least, these are the ones that we deal with word problems, then it's going to be a closed circle. And notice that this points to the right, so it's going to point to the right. Now, when we look at this, you see that the first thing we come to is the little point right here, so it's less than or equal. That means the point is included, and it's a closed circle, and it is pointing to the left because this points to the left. This one is greater than right here, the big open mouth, and it's equal underneath it, so it's going to be filled in. That means that point is included in the solution, and along with all the other points going to the right. The words at most is the less than or equal. So it is a closed circle. That means that point is included as well as all these points to the left. Now, if you see more than, it's a big open circle and it points to the right. So this points to the right. And less than or equal right here, no more than, is closed circle and it is pointing to the right, left. So you write this pointing to the left. And then you see the word exactly. There's the equal. There's no symbol with it, greater than, less than, so it's just a big closed circle. So make sure you have these down. Now, what we're going to do, how do you graph inequalities? So if you have x is greater than 2, you're going to read x is greater than 2. So underneath this, you will see that in open circle at 2, that 2 is not included in it. So if I were to put this as 0, put a -2 here and a 2 here, this is an open circle because 2 is not included in the solutions. All these numbers to the right of 2 would make this true. So if I had 3, I could put in 3 is greater than 2. I could put in 4. 4 is greater than 2. 5 is greater than 2. If I go this way right here, then 0 is not greater than 2. So all these numbers back this way are not included. 2 is not included because 2 is not greater than 2. It's equal to. But we're not saying that it is equal to right here. We're saying that it is not included. Now this next one, you see that x is less than 2. So I'm going to put 0, 2, and a -2. So since it's at less than and it's no equal, it's going to be an open circle. And all of these numbers to the left, see how this is pointing to the left? Then you're going to draw the arrow to the left. On the first one, you see that greater than was pointing to the right, so you draw the arrow pointing to the right. And this one is red right here, x is less than 2, an open dot at the 2 shows that 2 is not included. All the numbers less than 2 are included. That means if we had 0, 0 is less than 2, 1 is less than 2, -1 is less than 2, but 3 is not less than 2. So that's why all of these numbers over here is not included. 2 is not less than 2. Now when I look at the next one, I have x is greater than or equal to 2. So I'm going to put 0, 2, -2, and I could say that this time 2 is included in this and it is equal to it. So we can put 2 is greater than or equal to 2, 3 is greater than or equal to 2, and we can keep on going. On this one right here, you see that you have 0 and 2, -2. We see that x is less than or equal to 2. So I'm going to put a closed circle right here. And all of these numbers going this way are included because 0 is less than or equal to 2, 1 is less than or equal to 2, 2 is less than or equal to 2. But if we go this way, 3 is not less than or equal to 2. Now, how do you graph an inequality on a number line? So I'm going to look over here. The first thing that I see right here is that it is an equal sign. So that lets me know that -6 is included. And so I'm going to find a -6. I'm going to draw a closed circle. And I see that since this is pointing to the right, then all of these numbers this way are included. And that's how I'm going to draw my graph. Now, when I look at number 2, I see that there's no equal. And I'm going to find a 7. And 7 is right here. So I'm going to put an open circle this way. This is pointing to the left, so we're going to draw our arrow to the left because all of these numbers to the left of 7 are included in the solution. 6 is less than 7, 4 is less than 7, but 7 is not less than 7, 8 is not less than 7. Now, when we look at this next one, you see on the Sanchez family right here that when the Sanchez family is visiting an amusement park, when they enter the park, they receive a brochure which lists several requirements and restrictions, and you're to select the best answer. So look at number 13. As soon as I see number 13, you must be at least 50 inches tall to ride. You see the words at least right here. And if I go back and I go to the first page, you see the words at least right here. And that is greater than or equal. So I know I'm going to have greater than or equal. And anything it does not have an equal on it is automatically out. So B's out and D's out. And it has to be greater than or equal. So I know that it's going to be greater than or equal. So C is my answer right here. And I'm going to put a 0, a -50, and a 50. And since it is equal, I'm going to fill it in right here. And all these numbers this way make this is the graph for this one. Now look at number 14. Titling is an area of the amusement park set aside for children who are 6 years old or older. Which of the following inequalities represent the ages of the children who are allowed in titling? Now, when I look at this right here, I see that when I'm looking at this, we're looking at 6 years or older. So it has to be or right here. That can be exactly 6 years, or excuse me, not older, but younger. 6 years old or younger. So they can be exactly 6 years, so that means they can have an equal, and they can be younger, but they cannot be older. So this one would be A. That means that B and D were automatically out because they could be exactly 6 right here. So my answer to this one is A is less than or equal to 6. Now I'm going to put 0, 6, and -6. Since this is a closed circle, it's an equal. Then all of these numbers to the left are all the solutions. Now look at number 15. Children, and let me change my color. Now children less than 12 years must be, remember, less than 12 years. Children less than 12 years must be accompanied by an adult. The haunted house, which of the following, inside the haunted house, which of the following inequalities shows the ages of children who require an adult inside the house? So this one did not say anything about being equal or exactly 12. They can only be less than 12. So anything with the equal in it is automatically out. And I marked the wrong thing right here. So that means A and C are automatically out, and it's less than. So this one is B. And when I write this, I have 0, 12, -12, and it is a closed circle. So that means that they cannot be 12 and be able to go into the haunted house. They must be less than 12. Now look at number 16. On 16, the bumpy cars will not be turned on if there are 5 or more empty cars, 5 or more. Which of the following inequalities shows the possible numbers of empty cars if the ride is going to start? So as I'm looking at number 16 right here, I see that it has to be 5 or more. That means it can be exactly 5. It cannot be less than 5, but it has to be exactly 5 or more. So my answer to this one is C. And I'm going to put this down right here. So when I look at this right here, this is filled in, and it's going to the right because this is right here, less than, is pointing to the right. Now, when we look at this next one right here, Jim wants to save at least $40 for his trip to the amusement park. So far, he has $32. He plans to save X more dollars. Write inequalities to show the values of X that will allow Jim to meet his goal. So when we're looking at this right here, the first thing that sticks out in my mind is I see at least $40. So I'm going to box this off because we have to have at least $40. And then those, remember those when we were looking at this right back here? You see the words at least, that is greater than or equal. You're going to use these right here over and over again. So you want to make sure that these are handy, especially when you're working word problems. So when I look at this right here, you see that we have to have at least $40. We can make more than $40, but we want to save at least $40. So you can save more than 40. So far, you have $32 that you have saved up for the trip. He plans to save X more dollars. So we're going to put plus X and write inequality to show the values of X that will allow Jim to meet his goal. And so now we have 32 plus X is greater than or equal to 40. Now, looking at number 18, On number 18, you see the cost to rent a car is $18.75 plus, so I'm going to put a plus on the word plus, this 35 cents per mile. I'm going to put in my variable X on per. If you have $45 to rent a car, what is the greatest number of miles that you can drive? Now, when I look at this right here, I cannot spend more than $45. So that is the greatest number of miles. I can spend less than $45, but I cannot spend more because I do not have more than $45 on me. So I'm going to put $18.75 plus my 35 cents in my X is less than or equal to 45. Now, look at number 19. On number 19, Vance goes to the store to buy salad. And bags of pre-washed salad are on sale for $3 each. Write an inequality to show the possible number of bags Vance can buy. So the bags are $15 each, and he has $15 to spend, and the bags are $3 each. Now, he cannot spend more than $15. So we're going to start at the back because this is, you know that for sure. And then when I look at this, bags are $3 each, and there's my variable X, and that's all I have to do. Now, on this next one, you have the band. The school band will sell pizza to raise money for new uniforms. The supplier charges $100 plus, and I'm going to put a plus on plus, $4 per pizza. So I'm going to put my X right here. If the band members sell pizzas for the $7 each, so I'll put an X right here. How many pieces will they have to sell to make a profit? Now, remember the pizzas that they're going to sell are $7 each. They want to make more than this, but so we definitely do not want to cap it off at 7X. So I'm going to put down the 100 plus the $4 each that they will have to pay for the pizza. And remember, they're going to sell them for $7 each. And that's all you're going to do. Now, look at this next one. How do you write inequalities? So when I'm writing inequalities, the first thing I see that there's a closed circle on 0.4. So I'm going to put 0.4. I'm going to go ahead and put my X, 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 and X. It does not matter what variable you use right here. And then I see, here's the number 26. Here's the number 1/3, 1 1/3. And then negative 12. Now I'm going to change colors. So when I look at this right here, I see it's a closed circle, so that means it's equal, and it's pointing to the left. So I'm going to write it, my inequality symbol pointing to the left. This is a closed circle, so I know it's an equal. It is pointing to the right, so I'm going to point this to the right. This one right here is an open circle, so there's no equal, and it is pointing to the right. So I'm going to put the greater than symbol. This is an open circle, so there's no equal, and this is pointing to the left, and this is how I'm going to write it. Now, just like I went over earlier, right here, always make sure the variable is on the left-hand side right here, and if it's not on the left-hand side, rewrite it and make sure you flip the inequality symbol also. Now, you cannot have a negative variable. If you do everything by the negative, divide everything by -1 and turn the inequality symbol around. So as I look at this right here, you see you have a -1x greater than 2, so divide everything through by -1. And when you do, you're going to flip the inequality symbol around, so you have x is less than -2. Now, when we look at this right here, the first thing, like on 9, 10, 11, and 12, the first thing we're going to do is check to see if we have a variable on the left-hand side. And so on 9, we do have the variable on the left-hand side. So I'm going to draw a closed circle because there's an equal. And then I'm going to draw my line going to the right because this is right here is greater than or equal. Now on number 10, I see the variables on the right-hand side. So I'm going to flip everything around, including the symbol. And now I can graph it. So now there's no equal, so this is an open circle, and the arrow points to the left. Now on number 11, I see that I have a -1. So x, so I'm going to divide this side by -1, this side by -1. This will cancel out, and I'm going to change signs. So this cancels out, and I have x is -9. I'm going to flip the inequality symbol around. And I see that I'm going to find the -9. It's an open circle, and it's going to be less than. So I'm going to draw my line my arrow going to the left. Now on this one, I see that I have a -1m, and we cannot keep a -1m. Anytime that you have a variable, it must always be a positive variable. So we're going to divide by -1, divide by -1. This right here will cancel out. That will cancel out. So I have m, and we have to flip the inequality symbol. And -10 divided by -1 is a +10. Now, look at this. This is written backwards. So we're going to have to rewrite this. And now it's going to be m is greater than or equal to 10. Yes, it's back to where it looked like it was before. However, that now this has been worked out. It is a positive variable. So now I see a closed circle because it's an equal, and it's pointing to the right. And this is how you're going to do this. Look at this next one. How do you solve inequalities? You can solve inequalities in much the same way that you solve an equation. You isolate the variable by using the inverse operations. However, there's one major difference. When you divide or multiply or divide both sides of the inequality by a negative number, you must reverse the inequality symbol. So here are the same set of instructions that we use for solving an equation. If I were to take this first one right here and put 99 minus 5x equals to 4x. Now I can put plus 5x plus 5x. This cancels out, and I have 99 equals 99x divided by 9. And so x equals to 11. Now, when I work this one right here with an inequality symbol, I'm going to work it the same way. I'm going to, this time, I'm going to say minus 4x because we want to get our variables over to the left-hand side. This, oops, I canceled out the wrong ones. Now, notice on this first one that I worked out with the equals, it doesn't matter which side you put the variable on, but here it does. So this will cancel out to 0, greater than or equal to negative 9x, and this is 99. Now I'm going to put minus 99, minus 99. This will cancel out, and I have a negative 9x, greater than or equal to a negative 99. Divide both sides by negative 9. So our final answer on this one is x and 11. Now I always like to write my my symbol last, and because here's where I look at how did we multiply to both sides, multiply or divide both sides by a negative number. If the answer is yes, then you're going to flip this symbol, and the answer was yes. And so as you can see, our answer is the same. It's just the inequality symbol. Now, if we have a negative 3/7 x equals to 2, the first thing I'm going to do is get rid of the denominator. So I'm going to multiply both sides by 7. This will cancel out because 7 times a negative 3 is a negative 21. Divided by 7 is a negative 3x equals to 2 times 7 is 14. And divide this side by negative 3, this side by negative 3. So we have x equals to a negative 14 over 3. Or you can reduce it down to decimal. Now we're going to do the same thing over here on this other side. You're going to say, multiply this by 7, multiply this by 7, And 7 times negative 3 is a negative 21 divided by 7 is a negative 3x less than or equal to 14. 2 times 7 is 14. Divided by negative 3, divided by negative 3. This cancels out. And I have a negative 14 over 3. Now go back and ask yourself this question. Did I multiply or divide both sides by a negative number? So I'm going to check. Did we? And the answer is yes. So you're going to flip the inequality symbol. So notice that these answers are both the same thing. The only difference is the inequality symbol in the middle. Now, here's what we're going to do. We always, just like I just showed you, how to solve inequalities, we're going to follow these steps across here. So the first thing we're going to do is clear the fractions or parentheses, and we don't have any fractions in this one. So when I clear the parentheses right here, I'm going to go ahead and I'm going to say, bring down my 6b, and I'm going to make that a capital B so you can tell the difference. Minus 2 times b is 2b. Negative 2 times 3 is a negative 6. Less than 2 times b is 2b. 2 times a negative 5 is a negative 10. Now I'm going to carry all my variables to the left-hand side. And I also am going to, before I do that, I'm going to combine like terms. So 6b minus 2b is 4b. 6 minus 2 is 4. Minus 6 less than 2b minus 10. Now I'm going to undo an addition and subtraction. We're on step number 4. I'm going to change colors. So when I look at this right here, I'm going to put minus 2b, minus 2b. This cancels out, and I have 2b minus 6 less than a negative 10. And I'm going to say plus 6, plus 6. This cancels out. So I have 2b less than, and this is a negative 4. And remember, we've got to divide both sides by 2. So this cancels out, and I have b, and I have negative 4 divided by 2 is a negative 2. And before I write the final symbol down right here, I'm going to look at this. I'm going to go back and check right here. Did I divide both sides by a negative number? And the answer is no, and I cannot get my pen to write. So let's see if it's going to write now, and it's not. So the symbol does not change. And so this should be b is less than or equal to a negative 4. Now, I finally got my pen to working again, and so when we look at this right here, I circle and see, did we divide both sides by 2 or by a positive number? And the answer is yes, so we do not flip the final answer right here. So this is the way it's going to look. Now, if I look at this one right here, you see the first thing that we're going to do is, on example B, get rid of the variable. And I'm going to change colors because it's hard to see with the the yellow on white. So I'm going to put the denominator is 3. So I'm going to put a 3, 3, 3 right here. Now 3 times 2 is 6 divided by 3 will give me 2. 3 times a negative 5 is a negative 15. Greater than or equal, 7 times 3 is 21. So that we have cleared the fractions. There's no parentheses. We don't have any like terms combined. We're going to undo addition and subtraction, and we're on step number 4. So I'm going to put plus 15, plus 15. This cancels out, and I'm bringing down my 2x greater than or equal to 36. Now I'm going to divide both sides right here by the coefficient of x, which is 2. And so x is, and then we have 18. Now, here's where, remember, don't write anything down until you go back and check right here. And ask yourself this question. Did I multiply or divide both sides by a negative number? And if the answer is no, you do not flip it. And the answer is no, because these are positive numbers. So this is our final answer right here. Now, here's 2 more examples. look at example C right here. On example C, we're going to use distributive property. There are no fractions to get rid of. So when I have this one right here, -3, -4 times 3 is a negative. And let me cancel this out. And so this is a negative 12x. -4 times a -5 is a positive 15. Excuse me, a positive 20. Less than or equal. 2 times a -6 is a negative 12x. 2 times 10 is a positive 20. And now we're going to get the variable to the left-hand side. So I'm going to move the negative 12x, and when you undo a negative 12x, it becomes a positive 12x. So this cancels out, and now let's check your answers. This cancels out, that cancels out. I have 20 less than or equal to 20, and this is true. And if it's true, the final answer is infinitely, many solutions, or you may say all real numbers, and I'm going to use the abbreviation for numbers. So this right here is my final answer. Not the 20 is less than or equal to 20. Now I'm going to come over here and I'm going to start working the other side. So I'm going to say 2 times 2, 2 times a negative 6x. So 2 times 2 is 4. 2 times a negative 6x is a negative 12x, greater than. 2 times 2 is 8. 2 times a negative 3x is a negative 12x. I'm going to change colors so it would be easier for you to follow. Now remember, move your variable to the left-hand side. So I'm going to say plus 12x plus 12x. This right here, and I'm going to change colors again. This cancels out, and we have 4 greater than 8. Now, when I look at this right here, I'm thinking, okay, now I have 4. Is 4 greater than 8? No. So I'm going to put my line through it. That means that it is not equal, and this is false. So since this is false, then the answer to this is no solution. When we look at this next part, we're going to be looking at graph and linear inequalities. So the thing that you have to remember is this. As you look at this right here, you see that this side is shaded. You have solutions that are points in the shaded area only right here. The solutions, the answers to this will be found in this area right here. If it is a dotted line, which this is a dotted line, then you're is shaded above that. That means that the answer cannot be found on this dotted line right here. But the answer to the solution will be found right here. Now, when we look at this one right here, because this right here, y is a greater than x right here, you have y is less than x on this side. The solutions are points in the shaded area only. Now, every one of these, the only solutions you will find are in the shaded areas, unless you have a solid line across here. And these have solid lines, but these both on the top have dotted lines, so you will not find the solution on the dotted line, only in the shaded area. Now, when we look at this right here, and if it's less than, you're going to shade down below the line right here. This is less than, so you shade it down below the line. And if it's an equal right here, you're going to have a solid line right here. And the solution can be found on this solid line as well as the shaded area. Same thing right here. This is y is greater than or equal to x. And so the solution can be found on this solid line as well as above this shaded area. The solution, the answer to the inequality, cannot be found in the dotted line or the area that's not shaded. Now over here, here's the steps for graphing linear inequalities. Step number 1, you're going to solve the inequality for y on the left-hand side. Make sure it's on the left-hand side. Number 2, graph the boundary line, whether it's less than or equal or greater than or equal, it'll be solid lines. If it's less than and greater than, it will be dotted lines. Number 3, shade on the appropriate side of the graph. If it's less than or equal or less than, it means to shade below the line. Then part B, if it's greater than or greater than equal, you're going to shade above the line. Number 4, test the point in the shaded area to make sure that you have the correct side for shading. And don't forget that when you multiply or divide by a negative number, you must flip the inequality symbol around. And here again, make sure the inequality is written in the slope-intercept form. Right here, y equals mx plus b. And because if you divide by a negative, you must flip the inequality symbol. Now, looking at these right here, we're going to determine whether the graph of each inequality would be represented with a solid line or a dashed line on the coordinate plane. So I'm going to look at these right here. The only thing I'm going to look at are the symbols that's in between here. So on number 1A, see if you can come up with it. And when you're looking at this right here, if it's just less than right here, if it's less than or greater than, and you see this is greater than, there's no equal, then it would be dash, a broken line. Now, when I look at this right here, less than or equal, there's an equal, so that means it's going to be a solid line. So solid line means there's an equal, and if it's like on E, if there's no equal, then it is a dash or a broken line. Letter B, if you look at this, this has an equal, so that means it's a solid line. The solution can be found on the solid line. And when I look at D right here, there's no equal, so it is a dashed line. That means that the solution will not be found on that broken line. And then on F, it's less than or equal, so we have a solid line. Since it's equal, that means that the solution can be found on that dotted line as well as in the shaded area. Now, looking at this right here, part number 7, first thing we're going to do is get this in the slope-intercept form, which is y equals to mx plus b. And then we're going to graph using rise over run. So I look at this first one right here. The first thing I need to do is move the 3x over to the other side. And then when we move the 3x to the other side, that will get y by itself. So I'm going to look at this right here. This cancels out in half. 5y is greater than or equal. And we cannot combine these because these are unlike terms. So I'm going to write this in slope-intercept form with my x first. So I'm going to simply put minus 3x, negative 3x, plus 30. Now I'm going to divide both sides all the way through by 5 because when I look at this right here, we have a coefficient of 5. We cannot have a coefficient of 5, so I'm going to divide all the way through by 5. And this right here will cancel out. This cancels out and I have y, and I have negative 5 divided by y. 5 is a negative 3 over 5, x. And then 30 divided by 5 is a positive 6. Now, before I write down anything else, I'm going to check this part right here. Did we multiply or divide both sides by a negative number? And the answer is no. So we leave the symbol as is. We do not flip it. Now, look at this right here. My slope is a negative 3 over 5. My y-intercept is at 0, 6, 0, 6. Now, when I look at this, I'm going to start right here, and you are going to start on the B. So B, right here, start here. B comes before the M in the alphabet, so start with the B right here. So I'm going to go to the Y, and I'm going to find 0, 6. Now, this is our starting point. This is like bullseye right here. And I'm going to change that to a red. This is your starting point. Then I'm going to take my slope right here and I'm going to graph it. Since it's negative, I'm going to go down 3 steps and then step off the ladder, like climbing down the ladder 3 steps, and step off and go to your right. You must always go to the right. So when you're graphing these, so from the red, I'm going to count 1, 2, 3, and I'm going to step off and go to the right. 1, 2, 3, 4, 5. There's my point. If I wanted to extend the line, I could go backwards and count backwards. 1, 2, 3, and go backwards. 1, 2, 3, 4, 5. Now, I see that this right here, these are my 3 points, and this has an equal here. So this means that this is shaded. It's a solid line. And then we have to shade above the line. So it's greater than. So I'm going to shade up this way. Now, when I look at this right here by shading above it, that means that the solution can be found right here or on this solid line. Now, we can check this out. We can take this point of 0 right here. And 0, 0 is right here in the middle. And I can substitute 0 in place right here. So when I look at this, negative 3 over 5 times 0, 0 plus 6. So if I'm checking this point, 0, 0, 0, 0, right here. And I'm checking this. And I come over here and I put this in right here. Negative 3 over 5 times 0 plus 6. If you can use 0, 0, then use 0, 0 because you know this cancels out. So this right here would cancel out. And I have 0 is greater than or equal to 6, and this is false. And if this is false, because we're in the area that is not a solution, then that means that this solution will be found up here. And this is true. So now this is our answer for this one. And so if we were to check right here, let's say 0, 10. If we were to put 0, 10 in there now, and I'm going to change 0, 10. So I'm going to have a negative 3 over 5. And I have the points 0, 10. So this is my x and this is my y. And I'm going to substitute that in there now. And so 0 is right there and my 10 is right here. Now I'm going to see if this is true. This cancels out and I have 6. So it's 10 greater than or equal to 6, and the answer is true. So this is true. The shaded area is right here. Your solution will be found right here as well as here. It will not be found right here because this one was false, and it should be false. Now, when I look at this one right here on number 8, you see that you have to get y by itself. So I'm going to say minus 21, minus 21. And this will cancel out. A negative 3y is less than. Remember, do not combine these. We want to put them in slope-intercept form, mx plus b. And I have 9x minus 21. And remember, you cannot keep a coefficient in front of the y. It has to be a 1. So we're going to divide everything through by negative 3. Negative 3. And let me change colors again. So this right here cancels out and I have y. 9 divided by negative 3 is a negative 3x. Negative 21 divided by negative 3 is a positive 7. And when we look at this right here, you see that before I write down anything, I'm going to ask myself this question. Did I multiply or divide both sides by a negative number? And I look across there and I see a negative. If the answer is yes, then you're going to flip the inequality symbol. So now my slope is a negative 3 over 1. My y-intercept is at 0, 7. And I'm going to start at 0, 7 right here. So I'm going to find 0, 0, 7. And so this one right here, we're going to go up 7 places right here. And so when I look at this right here, I see that we're going to count up 1, 2, 3, 4, 5, 6, 7, and that one goes up more than I would want to. So we're going to have to go off of it, and I'm going to pause this while I change this right here and add to it. So now that we have our 0, 7, we're going to go to our slope, and you see that we have a -3 over 1. So I'm going to go down 3, 1, 2, 3, 1, 2, 1, 2, 3, and to the right 1. Go down, and let me change colors. So 1, 2, 3, 1, 2, 3. And then 1, 2, 3, run to the right 1. 1, 2, 3, run to the right 1. 1, 2, 3, run to the right 1. And notice that this time there is no equal. So this will be a broken line all the way across. Now that we have broken our line, and it says to shade above it. So I'm going to shade above it. And then you can test a point right here. So let's go and use our same point that we used a while ago. When I look at this right here, I'm going to say, let's check 0, 10. Let's check out this point right here, 0, 10. So when I put this in, I have 10, and here is, let me box that off, greater than, -3, 0 plus 7, and I have 10 is greater than, and that cancels out, is 7. This is true. So that point is a solution. So I'm going to put this down here, 0, 10. Now I'm going to check any points that are in the shaded area, it doesn't matter where. Find a point that is away from the other ones. Here's this one. So if I go from here and go straight down at 4, and then over here at 5, here's another solution. So I have 4, 5. I can pick any point that's into this shaded area, and it'd be a solution. Now, if I want a non-solution, 2 non-solutions, I can pick anywhere over here. And here is 0, 0. That's outside of that area. And then I can pick another one. I could say, okay, here's another one right here, which is -2 and 3. Okay? So now, let's look at these right here. We're going to answer these right here on number 5. So on number 5, you see the first thing that we are going to do is put our Y and Y. I see that this is a broken line and it's shaded down below. So I'm going to put less than right here. Now, to see if it is greater than or less than, I'm going to look across here, and right across right here is, I see, when I'm counting these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This side is 12. Over here, the shaded area is 1, 2, 3, 4, 5, 6, 7, 8. And this side is smaller, so it has 8. So this is the side that should be shaded. Now, when I look at this right here, the first thing I'm going to do is find the y-intercept. The y-intercept is at 0, 2. And then I have to find the slope. So to find the slope, I'm going to find a corner. And here's a corner. That line is going through this corner, going through this corner. And I can draw a triangle. It doesn't matter if you draw above or below. Now I'm going to count the rise on this. 1, 2, 3, 4. And I see this is a positive. It's going uphill. And then it's a run going across. So my slope on this one is 4 over 1. Reduced down is 4. And then I'm going to write it in slope-intercept form, which is y equals to mx plus b. So I'm going to put a 4 right here, x, and then my y-intercept is at 2. Now I've just written that. Then come over here. I see that this time that right here, the shading is above the line. So I'm going to put greater than, and I see that this is a solid line, so I'm going to put an equal right here. Now my y-intercept is right here at 0, 10, and I've got to come up with my slope. Now I see that this line is going through every point right here. It doesn't matter how big or how small you write your triangle or draw your triangle. So I'm going to draw my triangle, and I see that this is going downhill, -1 over 1. So my slope right here is a -1 over 1, reduces down to a -1. Now, when I write this, my slope is a -1, so I can put a -1x, and you don't have to put the 1 there, but I did, plus 10. Let's look at the next one. Now, on this one, on number 7, as we look across here, I'm going to remember, write in slope-intercept form, y equals mx plus b. So I see that I have y is shaded down below right here. So it's less than. There's a solid line, so it is equal. And I'm going to go ahead and do number 8. So y right here is shaded above the line right here. And it's a dotted line, so there's no equal right here. Now, I'm going to find my y-intercept, which is at 0, -2. And then I'm going to find my slope. And I've got to find a line, where the line goes through a corner right here. I can use any of these points right here. It does not matter the size. It doesn't matter if you draw it above or down below. It doesn't matter. You can use any of these right here, any 2 points. And I look for the 2 points that are the closest together. So my rise right here is 1, 2, 3. My run is 1, 2, 3, 4. I count on the outside and count the blocks. So my slope is rise over run. Now, as I write this down right here, I'm going to put 3 over 4. And I have 3 over 4x minus 2. Number 8. My y-intercept is right here at 0, 1. Now, we have to come up with our slope. So we're going to look for, where does this line go through a corner? It goes through a corner everywhere. It doesn't matter which 2 points. Just find 2 points are beside each other. Now, my rise is 1. My run is 1. So my slope right here is 1 over 1, which reduces down to 1. And it is a positive 1, so I'm going to put a 1 right here. So I'm going to put a 1x, and my y-intercept is at 1, so plus 1. Now, I could have written it like this without, don't put the equal though. Now, I could simply left off the 1 and just put x plus 1. Now, let's look at number 9 right here. On number 9, as we're looking through here, we're looking to see which graph would match the following inequality. So the first thing I'm going to do is check this out right here, the symbol. I see the symbol is this. There's no equal. That means there's no solid line. Well, none of these have solid lines, so you don't have to worry about that. Then it's less than, so that means it's shaded down below the line. Now, in order to tell if it's less than or not, which side it's shaded on, count the blocks across here. I see I have 1, when I'm looking right here, 1, 2, 3, 4, 5, 6, 7, 8. So this is the less than side. And then notice over here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right here. So now, when I'm looking at this right here, I see, well, this has to be less than, it has to be shaded below the line. So this is shaded below the line, this is shaded below the line, this is shaded below the line, so is this one. So now, since they're all shaded below the line, we have to look at this right here. Our m is -3 over 1, and the y-intercept is at 5. So I'm going to check. Look at the first one. Is the y-intercept at 5 right here, 0, 5? No. So this one is out. That would be no. Then is this one at 5? No. It is 0, 4. So this is a no. Is the slope, is the y-intercept at 5 on this one? And I see that this one is at 0, 6, 7, 8, 7, 8, 0, 8. So this is no. Now, when I look at this one, I'm looking, is this right here at 5? As I'm looking, and I see that this right here is crossing. Let me see this again. Well, trying to get it to bigger for you. This is at 0, -6. So no, this is not it. Now let's go back and double check these others and make sure that we did not make a mistake. Oops, let me get this out of the way and get this back to small. And this one, as we're looking at it, it has to be a negative slope. This is a negative slope and this is a negative slope. These are positive slopes, these are positive slopes. So these two would automatically be out, C and D. And we're looking for a negative. It has to cross at a +5. And I see this crosses at a +4. So none of these would be it. So that was this one. Sometimes that happens. So they should have had another one right here. And it's not here. Or say none of these would be a better choice. None of these, which could be very well be correct. So this one does check. Now, looking at these problems right here, you have Nora that's planning a birthday party for her little sister Colleen. Nora's budget will allow her to spend no more than $50. So she cannot spend more than $50. 8 children, including Colleen, will attend the party. Nora wants to determine how much she could spend on party favors for each child. She will also have to purchase a cake for $10. Now, we know that we have 8 kids right here. So I'm going to put 8C for children. We know that she's going to spend $10 on a cake. And we know that she can spend less than 50, and she can also spend exactly 50. Now we're going to work these out, and I'm going to change my colors. I see this cancels out, and so it's 8C is less than or equal to 40. Divide both sides by 8. So now we have C and 5. And remember, always come back and write this part last, because you do not want to have if you divide by a negative number, you have to flip the inequality and ask yourself, did I divide both sides by a negative number? And the answer is no. So we keep the symbol the same. So she can buy 5 right here. Because you're answering, Nora wants to determine how much she can spend. So she can spend $5 on each party favor. Look at this next one. Look at number 11. Zachary is planning to spend a video game, is planning on sending a video game to each of his 2 brothers. If he buys the same game for both brothers and pays $4.75 to ship each game, how much can he spend on each game without spending more than $100? Right inside the inequality for this situation. So that is the most that he can spend. He cannot spend more than that. Now, so as I look at this right here, he can spend exactly $100, but he cannot spend more than this. So you have 2 brothers right here. And as I look at this right here, he's going, if he buys the same game for both brothers and pays $4.75 for shipping. So he's going to buy the same game for both brothers. So this is your gain plus your shipping. And let me move this over right here. So you have $100 that he can spend. He can spend exactly $100, but he cannot spend more than that. Now we're going to use distributive property. 2 times x is 2x, plus 2 times $4.75 is $9, $9.50. Less than or equal to 100, minus 950, minus 950. This cancels out. You have 2x less than or equal to $90.50 divided by 2. And you have x is 45, 25. And ask yourself this question. Did I multiply or divide both sides by a negative number? Right here, we're going to check. The answer is no. So keep the symbol the same right here. Okay. Now, look at this next one, number 12. You have on this one, I'm going to go ahead and change colors. The daily info charges $6.50 plus, so I'm going to put a plus right here, $80 per week to run an ad. The People's Paper charges $1.45 per week. For how many weeks must an ad run for the total cost at daily info to be less expensive than the cost at People's Paper? So the first thing I'm going to do is look at the first sentence. So in the first sentence, all this goes together. So I'm going to put 650 plus 80x. And remember, we want it to be less expensive. So we're going to put less in. And I'm going to change colors again. So when I look at this right over here, the People's Paper is this. So I'm going to put the 145x over here. So I'm going to take this right here, and I'm going to take negative 145x, negative 145x, and this right here, and I'm going to change colors, will cancel out, and you have 650, and I'm trying to get it to write, 650, and it's not wanting to write. Okay, it's having trouble again, so let me pause it while I work. Now I finally got my stylus to work, so I just went ahead and worked out these last two problems for you. And so when I work these all the way out, and I added undo addition and subtraction and get down to the bottom right here, I see I have a negative 65x is less than a negative 650, and you're going to divide both sides by a negative 65, and you see bring that this cancels out, bring down your x. Negative 650 divided by negative 65 is a positive 10. And before you write the symbol, always ask yourself, did you divide both sides by a negative number? If the answer is yes, you flip the inequality symbol. So you see that this right here is your answer right here. Now, make sure that you box off your answers as you're working them so that they will stand out. Now, when we look at number 13 over here, the school band will sell pizza to raise money for new uniforms. The supplier charges $100 plus, and I put the symbol plus on the word plus, $4 per pizza. So there's my X per. If the band members sell the pizzas for $7 each, and I put the X, my variable on each, how many pizzas will they have to sell to make a profit? So the first sentence right here goes on the left-hand side. The second sentence goes over here. The second sentence right here goes on this right-hand side. Now we're going to make sure, write your variable on the left-hand side. And so when I work all the way through it and get down here to the bottom, I see I have a negative 3x less than a negative 100. And so we're going to divide by negative 3. And we're going, when we divide all the way through, you see that negative 100 divided by negative 3 will give you a positive 33.3, and the 0.3 keeps repeating forever and ever. Now, it says how many pizzas will they have to sell to make a profit. Well, when you're trying to make a profit, you have to round up, even if it's a 0.1 right here, because you want to make a profit. If you just sold 33.3 pizzas, then you would just break even. And plus, you can't sell just a third of a pizza. You have to sell the whole thing. So you either round down to 33 or round up. If you round down to 33, or like you normally would round off, then you would be short. You would not even break even, because it takes 33.3% parts of a pizza, or 33 whole pizzas